We have Selling Genes and Buying Race by Professor Lisa Ikemoto. Lisa is the Martin Luther King Professor of Law at the UC Davis School of Law and a bioethics specialist. She has written extensively on genetic and reproductive technology and on regulation of fertility and pregnancy and on race and gender disparities in healthcare. She's currently focusing on emerging issues in regenerative medicine, including stem cell research and on human tissues market. Earlier this year, Professor Ikemoto was interviewed by 60 Minutes about the potential downsides for consumers who upload their genetic information to genealogy websites. And with that, I will turn it over to Lisa. Lisa, it's all yours.
Thank you, Dave. Thank you for inviting me to participate in the Renaissance Society Forum Speaker Series. I am really honored, especially given the lineup I saw of other speakers on this forum. I look forward to chatting with you today. And just to start, as a researcher, I track how markets in human cells, tissues, and genes are formed, and how the science of genomics interacts with social cultural discourses, including that of race. So now we can switch to the slides. Thanks. So this talk is an invitation to examine with me the interaction of science, markets, and race. Next, please. Black Lives Matter, the confluence of Black Lives Matter and the pandemic have prompted widespread recognition that structural racism contributes to illness and death. That knowledge isn't new, but it hasn't been the subject of a major national discourse until very recently, until the past 18 months. And I think part of the reason is because it's not shiny. And like magpies, we have long prioritized, both in science and society, shiny objects. Next. The shiny object in biomedicine has been the human genome. In 1990, the US committed $3 billion to map the human genome. It's now called the Human Genome Project. Big science and the exciting new information it produced sort of became this giant magnet. It pulled the collective attention of science, research funders, and the public. It created a lot of exciting information, and it also created a lot of hope and hype over the idea that our genes could explain illness and lead to cures. So research on health disparities in the past 30 years has focused heavily on the role of genomic differences as a source of health disparities, and much less on the role of factors like structural inequality. And then more generally, what grew from our fascination with genes is the idea that genetic variation can explain not only health and disease, but also who we are. That shiny idea shaped both research agendas and our social thinking. Next. So social scientists have used the term genetic essentialism to capture that idea, the belief, the faith, that the gene can explain everything. So we've distilled ourselves down to our genomes and the variations within them. So even to the point where many believe that our political views and our views on racial difference, or understandings of racial difference, can be boiled down to genetic variation. Next. Human genome scientists have estimated that 0.01% of the human genome accounts for racial difference. And in fact, when the National Institutes of Health announced that the Human Genome Project had been completed, they also announced that 99.99% of genomic variation has nothing to do with race, and that you can find more variation within any one group that you call a race than between any racial groups. Craig Venter and other geneticists have said repeatedly that race is a social concept, not a scientific one. Venter is one of many researchers who contributed both to the sequencing of the human genome and to the commercialization of that work. So what does it mean to say that race is a social concept? In the US, our insistence that race matters is so pervasive that it shapes interpersonal relationships, self-identity, our institutions, and our culture. And we know that it's a social construct because not all societies use the same racial categories, and not all countries or societies use race as their primary social political categories. For example, in some countries, including many in South America or Latin America, the primary identity categories are formed and explained by affiliation with indigenous and or colonial ancestors. Next. So despite this, the idea that science and genetics in particular explains most of what we think of as racial difference has grown. So for example, in 2013, Nicholas Wade, a popular New York Times scientist or science writer, published a book called A Troublesome Inheritance, Genes, Race, and Human History. And some of this book was scientifically accurate, but he also claimed that genetic research shows that genetic factors explain traditional racial stereotypes, in a sense that those stereotypes are justified. 139 geneticists wrote a collective letter refuting Wade's claim. And yet our insistence, our faith that racial difference is biologically based, is being imprinted on genome science and on the genome market. So the resulting product, genetic race, is affecting research, medicine, and our social lives. And I use the term product deliberately because genetic race now sells genes. Next. So I'll discuss that point in a few minutes using two examples. So this slide is meant to sort of identify those examples. One is direct-to-consumer genetic testing, and the other is what I think of as direct-to-consumer biobanking in the form of sperm banks and egg agencies. But before I do that, I'm going to back up and talk about how we came to have markets in human tissues and genes. Next. So the person depicted on the left of this slide is John Moore, a man named John Moore. In the 1970s, John Moore was diagnosed with a blood cancer, hairy cell leukemia. And he was referred to a doctor at UCLA. So he went down to Los Angeles, and Dr. Gold at UCLA, in fact, confirmed his diagnosis of hairy cell leukemia, and in the process noticed that John Moore's spleen was grossly enlarged, dangerously so, and he recommended a splenectomy. So John Moore underwent the splenectomy at UCLA, signing the standard consent forms for surgery. And very shortly after that, the hairy cell leukemia cleared, and he was declared to be in remission. But over the course of the next 7 years, he received follow-up care at UCLA. He in fact lived in Washington, so over the course of the next 7 years, he flew down to UCLA on a regular basis for what he was told was follow-up treatment. And as part of the so-called follow-up treatment, the doctors collected many types of tissue and cell samples from him, including blood, bone marrow, even semen, among others. Near the end of the 7-year period, John Moore received a letter in the mail from Dr. Gold in UCLA asking that he sign a consent form that would be applied retroactively to the use of his cells and tissues for commercial purposes. So he didn't sign it and return it as requested. He went to a lawyer and said, "What's going on?" And the lawyer did a little research and found out that UCLA was already in the process of perfecting a patent on a cell line that Dr. Golden and another researcher had created using John Moore's spleen cells and all the other samples that they had collected from him. John Moore felt betrayed. He was upset and he sued. And that case went to the California Supreme Court. And what's interesting is that this happened during a period that the biotechnology industry was undergoing its first boom. It was emerging in a major way. And in part, that was facilitated by breakthroughs in science that enabled the creation of cell lines that could then be turned into valuable products, like the Mo cell line that was created from John Moore's cells and genes. But also, it was spurred by enactment of a federal law called the Bayh-Dole Act. So this federal law was based on the idea that at that time, the majority of federal funding for biomedical research came from the federal government, going to academic institutions, nonprofit organizations, and biotech companies as well. And it turned out that the federal government, because it had funded, kept the patents on that research. But it wasn't particularly good at using those patents to leverage products that would make it to the market. So the Bayh-Dole Act was meant to facilitate that process. So it gave the patent rights to the research institutions. And what resulted is what's now common practice. So if UCLA makes a breakthrough, for example, creates a cell line that has great research and commercial development prospects, it creates a partnership with entities like Sandoz Genetics Institutes, which in fact it did in the John Moore case, for commercial development of products. And there would be profit sharing if anything valuable resulted. So when John Moore sued, he sued not only Dr. Gould and the other researcher, Dr. Kwan, he also sued the University of California as a patent holder and the University of California as commercial partners in that. He filed 13 claims in his initial lawsuit, and 2 of them made them up to the California Supreme Court. One of those claims was a claim for breach of fiduciary duty or a breach of informed consent. And the other was a claim for a tort called conversion, which is based on the idea that he would have a property interest in his cells and tissues and anything that resulted from them. So when the Supreme Court received these 2 issues, its job was to decide whether or not John Moore could in fact proceed to trial on either of those 2 claims. And with respect to the breach of fiduciary duty, the court said yes, because Dr. Gould had failed to mention in any of the informed consents until near the end of the 7-year period that they had not only been treating him and making sure that he stayed healthy, but they had also been using his cells and tissues for their own purposes, for research and with the hopes of developing something commercially profitable. And by failing to disclose their financial conflict of interest, that they had violated or may have violated the duty to disclose and the duty of informed consent. With respect to the property-based claim, the court said no. And the analysis started out by saying that, well, yes, we all have a property in our own body in a sense, but once those cells and tissues and genes are removed from our body, things are different. And in that part of the analysis, they looked at existing law to see to what extent what existing law had to say about sort of sources, the people who provided those cells and tissues and their ability to control the use of the cells and tissues once removed from their bodies. And for example, they looked at laws like medical waste laws. Medical waste laws say, for example, if you undergo a splenectomy or an appendectomy, then you can't take that home with you and put it in your freezer. That in fact, it has to be incinerated. It's treated as medical waste. So you have relatively little control or say so over what happens to it after it's removed from your body. The court took laws like that and a few others and said, well, that shows that you really don't have anything that amounts to a property interest. You don't have enough control over those cells and tissues to say that you have a property interest in your cells and tissues. And therefore, John Moore cannot proceed with this claim. The court also considered the policy concerns at stake, including those of the emerging biotechnology industry, and they had filed a brief in this case asserting those interests. So the concern that was recognized by the court was that if you had people like John Moore whose cells and tissues had been used, and they could now assert a claim against the research institutions that had used their cells and tissues, that would prove to be very costly for the research industry, and in fact might stymie the progress of research, and the progress of research was a public good, or the results of research were a public good. This opinion issued by the California Supreme Court was issued in 1990, which, as I noted before, was the same year that the US launched the Human Genome Project. Next. So the result of Moore is that, yes, John Moore was able to proceed with his claim that Dr. Gould had violated the fiduciary duty that he was owed because he failed to disclose his financial conflict of interest. But what it also means is that in any informed consent, if there's a disclosure of a potential financial interest by the researcher, doctor, or the research institute, and you sign the informed consent, then in a sense you've given up all rights or claims to how those cells and tissues are used. You've transferred them, in a sense, to the research institute or to the researchers themselves. And so the Moore case has become biotech's favorite rule. And in fact, it's probably the University of California's favorite case. But what it's done is it's helped grow the practice of biobanking. So I have an image here, and it shows that the collection of human cells, tissues, and genes is what's known as biobanking. It's a very valuable practice because it provides the raw materials for very important biomedical research. But those biobanks are also very valuable capital assets. In fact, several multi-billion dollar companies are themselves biobanks, and they sell access to the information within those biobanks. So biobanks have become what is now called biocapital. So on the one hand, yes, we get a lot of valuable information, research, important therapeutic products from those practices, but it also positions people who are often patients as the source of the raw materials for biotech. On the one hand, informed consent seems an adequate source of protection. As long as you say yes or no, then you can decide whether or not you want your cells and tissues used by others for research and commercial exploitation. But it doesn't always work. Next. So I am a patient in the UC Davis health system. And whenever I go to the doctor, I present my insurance information. They update my contact information just as they do for every patient, and I sign a form. It's just part of the routine of going to the doctor. So this slide shows a portion of that form. It's called a patient services agreement. It's 1 page long and you sign at the bottom, or nowadays you sign on an electronic pad. And buried in the middle of this patient services form in paragraph 4 are 2 sentences. So the highlighted portion of the slide shows that language. I understand that my health information may be used and shared with researchers who engage in research, teaching, and study related to my treatment, health condition, specimens, and/or medical or physical status. Additionally, as a result of potentially commercially useful products may be developed, and I understand that I will have no ownership rights in these products. And with that, every time I go to the doctor, I transfer the rights or any rights that I might have had, any limited rights I might have had, and agree to become the source of a biobank available for commercial exploitation. Next. All right, now back to my 2 examples. So commercialization and the markets for genes and tissues has evolved, and the practices have evolved as well. And some of these are going to be, these examples may be familiar to you, and some of you may have even used these services that I'm talking about. So the 2 that I mentioned are direct-to-consumer genetic testing, and this slide is a screenshot of a web page from 23andMe, one of the 2 biggest direct-to-consumer genetic testing services. So the model for these companies is that they sell these test kits. In the process, if you want something like ancestry information from your spit sample or health information from your spit sample, then you purchase the range of services that you want. You fill out a form providing a lot of personal information. You send in your spit sample, and then you get a series of reports. And that's what you receive in return for your $99 as advertised on the web page. And then on the other hand, what 23andMe gets is they get use of your spit sample, assuming that you got disclosure and gave consent, which most people do to use of that. So they're increasing their biobank by use of your spit sample. And most people say yes to this use. And some of these companies, not all of them, but some of these companies then sell access to the biobank that they're holding. So in fact, for some of these companies, the biobank that they're accumulating with your spit sample is in fact their most valuable asset and the probably most productive revenue stream that they have. So they're selling it. They might be doing research using that biobank themselves, or they, in a sense, what they're doing is outsourcing the possibility of doing the research using their biobank that they've accumulated. And then on the other hand, what we have is during the same period of time that we've been talking about, largely from the late 1970s up till now, the growth of what is now known as the fertility industry, which is based on assisted reproductive technology use. And those uses include sperm banks and egg agencies, which, as I said, I think of as direct-to-consumer biobanks. So both these direct-to-consumer genetic testing kits and the sperm banks and egg agencies use ancestry, race, and ethnicity to market their products. And so that explains part of what I meant by my title for the talk today. So part of what's interesting and maybe confusing to many is that ancestry, race, and ethnicity are often used synonymously by these companies. And I think one of the concerns that I have is that encourages the conflation between race on the one hand and historic geographic ancestry, which is what these services purport to offer information about. So when race is used in medicine, it's supposedly used as a proxy for ancestry. Sometimes race is a good enough proxy, and sometimes it's not. And I'll give you a couple of examples. So one is that if you're an Asian woman, and I'm basing this on the story told by one advocate, a Japanese American woman who, when she was relatively young in her 30s, discovered a lump in her breast and went to a doctor, and she was told, oh, don't worry, Asian women don't get breast cancer. So she went away, but the lump progressed, and she was subsequently diagnosed with a very aggressive form of breast cancer. So the delay affected her treatment and her survival rates. So part of what was happening at that period of time was that this conflation between race and ancestry took place in a way that produced misleading information. It was true that women living in East Asia at the time had lower rates of breast cancer, very small rates of breast cancer compared to people of Asian descent living in the United States. But the data came from East Asia, so it looked like Asian women didn't get breast cancer or had at least had a very, very low risk, a negligible risk of breast cancer. And it turns out that women of Asian ancestry living in the United States had the same risk of breast cancer as other women who have lived in the United States. So that's one example that I'll give. And the other is the sickle cell example that many more people might be familiar with. So the assumption there is that Black people are at risk for sickle cell, for sickle cell disease. And that's true in part, but it's also true that populations whose ancestry traces back to certain parts of the Mediterranean region of Europe are also at risk for sickle cell disease. And so because of that, there's sort of a failure screening. In other words, too narrow of a population is being screened for sickle cell disease. So those are two quick examples to show the risks of and the gaps that arise as a result of using race as a proxy. It's an inaccurate proxy for the populations that really matter in genetics. Next. So in the fertility industry, in sperm banks and egg agencies, race is offered to intended parents as a trait they can select. It's offered almost as a genetic trait. Really what you're doing, if you're trying to decide which sperm to choose or which egg donor to use, is you're choosing a donor and their profile, if you will. But you could see that it's offered as if it's separate from the person. So this is a slide from California Cryobank. California Cryobank is, I believe, the second largest sperm bank in the global market. And yes, there's a global market in human gametes. The largest company, the last time I checked, was Cryos, which is based in Denmark. So you can see that race is being offered as a genetic selection. And in fact, what these sperm banks and egg agencies do is they offer selections at different levels, if you will. So first, there's the screening or selection that the sperm bank or egg agency engages in itself. So it takes applicants to be sperm donors, for example, and then selects among them based on things like medical history, their responses to questions that they're asked. But it also makes selections based on what they think demand is at that particular time. So a few years ago, Cryos announced that it was no longer accepting donors with red hair because they had sufficient supply of donors with red hair. So, and apparently there's a relatively small market or small demand for donors with red hair. And then the next level of selection that you get is those made by the intended parents choosing from traits like this. You get a lot more information if you pay a fee to go deeper into the biographies that are available in the catalogs of the donors of these sites, but you get a little bit of picture here. Next. So this is a screenshot of a web page from an egg agency called Family Inceptions. And again, what it's showing you is that race and ethnicity are features that one can choose. So racial diversity sells. Racial diversity sells sperm, it sells egg donors or access to egg donors, and it sells direct-to-consumer genetic testing kits. It also sells research biobanks as well. So the more diverse your biobank, the more valuable it might be in dollar terms as a capital asset. In these consumer contexts, different understandings of race are brought to bear. So not if you and I are using a genetic test kit or selecting sperm because we're positioning ourselves as intended parents and hoping to become parents with use of these gametes, we may or may not be thinking about genetic race. We're hoping for a child who looks like family. But in that process, of course, we have certain race-based notions of what looks like family. So it's clear that what's being offered, whether or not it's scientifically accurate, is this notion of scientific race. And this jumble of ancestry, race, and genes offered for acquisition echoes the foundations of property and nation in US law. It's part of a resurgence of a very old idea called scientific racism. Next. So we're going to make an odd turn now in the conversation. I'm going to try to do this quickly. This is Johnson versus McIntosh, is an old case. You can see it was decided by the US Supreme Court in 1823. It's the first of three cases that are now called the Marshall Trilogy. The main opinion was written by then Chief Justice John Marshall. And the three cases together sort of set the framework for the relationship between the US government and the indigenous nations in the United States. Johnson versus McIntosh, the case I'm going to talk about for just a couple of minutes, also set the foundations for property law in the United States. So in this particular case, you have competing claims to at least what the Supreme Court recognized to be the same pieces of land. So McIntosh says, well, I have a better claim because I took my deed or my grant directly from the US government shortly after the US government became such. Johnson says, I have the better claim because I can trace it back further. My claim was purchased by my predecessors in interest to purchases from the Piankashaw, Illinois Indians. So when the Supreme Court looked at this case, they first had to decide, or at least they said they had to decide, whether or not the Piankashaw, Illinois Indians and any other Indian or indigenous peoples in the United States were capable of having ultimate title or property rights in the land that they held. And so next. The court did this interesting maneuver. They said, well, yes, we have to acknowledge that there were people when the European discoverers arrived in North America. There were people already here, and yet they only had what we're going to call the right of occupancy. And that when the European discoverers arrived, what they acquired was a right by discovery. It was subject to the Indian right of occupancy, but still they acquired a right just by arriving. And that right was then attributed to the governments that they represented. Next. And that right held by those nations gave them an exclusive right to extinguish Indian title of occupancy, as the court called it, either by purchase or conquest. So Indian title of occupancy could be extinguished by purchase or conquest. Next. The justification for this rested on what I just mentioned is called scientific racism, an idea that arose during the Enlightenment period. And you can see it here captured in some of the language from the opinion in Johnson versus McIntosh. Describes the Indians as savages And basically this excerpt makes 2 points. One is that the Indians of the time were sort of lacked the capacity to perform the activities on the land that counted under Western norms, European and then US norms, as possession of the land, which gets you ultimate title. And the other point that's made, I think, clearly in this excerpt is that in part that's because the Indians were ungovernable. They were deemed to be ungovernable by law in this opinion. Next. So this echoes very closely the understanding that the races of man, as they were called at that time, were biologically different. And in fact, not equal, but could be ranked in a hierarchy. And this is just an image from sort of what was understood to be science at that time. And it's interesting how the language of the court very much closely echoes so the language used to set out this theory of scientific, that we now call scientific racism from the Enlightenment period. Next. So in this slide, I'm just trying to capture what struck me when I teach property law as well as bioethics, is that the logical framework that's used in both the Moore case and the Johnson case are strikingly similar. They both use a two-step analysis. And in the first step of the analysis, in both cases, that's what I tried to capture on the slide here, the court first makes a finding that John Moore or the Piankashaw, Illinois Indians, in a sense, don't have ownership in the thing that they're trying to claim property to. So the Indians don't have ownership in the land that on which they've lived and held their families and farmed for years at that point, because they lacked the capacity to fully possess it as Europeans did. And John Moore didn't have the capacity to own the cells and tissues that had been removed from his body because of pre-existing law, like the medical waste law that I mentioned before. The second step of the analysis just then says that, well, for example, by purchase or by consent, as in the Moore case, even though they don't have ownership rights, they have the ability to transfer what limited interest they have to others who can then acquire ultimate title in that property. So both cases are about transfers for use by commercial, for commercial exploitation. Next. So the Moore case shows us that the two-step logic can be applied without racism, but scientific racism used in the Johnson case certainly persists. So on the left, this is a photo from Henrietta Lacks, and it's the same photo that Rebecca Sklootz used in her book about Henrietta Lacks and the cultivation of the Gila cell line. So Henrietta Lacks was a young Black woman who was experiencing symptoms and went to a doctor at Johns Hopkins University in 1951. And she was diagnosed and treated there for an aggressive cervical cancer. And a lot of what Rebecca Skloot's book did was reveal the role of structural racism in the life of Henrietta Lacks and sort of how that resulted in the separation and sort of also almost disappearance of Henrietta Lacks' own story from that of the cell line and how that became famous instead. So Henrietta Lacks' cancer cells were sent for biopsy to a cancer researcher who had been trying to cultivate a cell line. And there had been no success in doing that, creating a cell line that could survive on its own in the lab, but he achieved success with Henrietta Lacks' cancer cells, in part because they were biologically unique. So Henrietta Lacks died in October of 1951, but her cell line lives on, and it has become famous. Gila is famous in the biomedical world. Johns Hopkins didn't patent the cell line and shared it with other researchers. Initially, the cell line was anonymous. The source was not identified. Next, this is our last slide. In the mid-1960s, Henrietta Lacks' identity became known to researchers. Maybe they didn't know her as Henrietta Lacks, but what became known was that Gila came from tissue from a Black woman, a poor Black woman, with cancer, an aggressive form of cancer. And after that, what this quote shows is that description of the cell line in research articles and press accounts echo stereotypes of Black women. The cell line was described as being unruly, too strong, and like the indigenous people of North America, ungovernable. So capture and reproduction of those cells became a core activity of the research that led to the Moore case that enabled profit biobanking and direct-to-consumer services which trade on genetic race. And incidentally, the doctor who diagnosed and treated Henrietta Lacks was Howard Jones. Howard Jones and his wife, Georgiana Jones, were pioneers in vitro fertilization. They founded the clinic that oversaw the conception of the first IVF baby in the United States. And that was the beginning of the US fertility industry, which also sells race. I look forward to chatting with you now.
Okay, thank you very much. And we're going to now switch back here to my portion. And okay, so we're going to do Q&A right now. So there are about 7 questions. Please know that you can continue to ask questions. So the first one actually was about whether the governments retroactively gave patents to the universities.
And the question is whether they did that?
Okay, so, in the beginning, I think you indicated that the government gave the patents to the universities to use, right? Did they give them to them retroactively?
No. So the Bayh-Dole Act became effective in 1980. So from that point, universities it federally funded research that resulted in a patent, gave the universities the right to control those patents. And as I said, what they typically did was then use sort of control of those rights to form partnerships with biotech companies.
Okay, thank you. Next one is about medical waste. Are the medical waste laws the same across all states?
No, there's some variation. So the example I have is because I do a lot of research on reproductive health and rights as well. Some states, for example, allow you, if you're a woman who's given birth in a hospital, in some states you can actually take home the afterbirth, what's called the afterbirth, because some people will use that for ceremonial purposes, for example, but some states wouldn't allow that. And the laws have also evolved over time. When I was young, and I'm giving away my age, if you had your tonsils removed, you could take them home and show them to your friends. So you would take them home in a little jar. And I believe that's no longer permitted in most states.
Okay. There's 2 of them that are pretty much the same, which is not surprising when you got to that, the release form. So what happens if you refuse to sign or strike through the sentences? And the second one was, can someone say no or cross out the language on the hospital forms?
Yeah, I do that. I got harder when my doctor's office started using an electronic signature pad, but what I do is I ask for the paper copy. And, in the years when I'm feeling sort of, annoyed by this, then I cross out those lines and I initial it. Yeah, so you can do that. Yeah. But I hope that you'll all read your consent forms more carefully now.
I certainly am. No.
Yeah, I mean, I think some people are happy to allow the use of their cells and genes to be used because it might result in medical progress. But maybe we should be a little bit wary.
I agree. Okay, so what is the difference between race and ethnicity?
Yeah, that's a good question. It's mostly, it's how we use them socially. So race, as I mentioned, is largely a social concept, if not exclusively a social concept. And it varies probably within the United States. For a long time, when we talked about race, we focused almost exclusively on Black and white. For census purposes, if you track, a friend of mine sort of has been tracking the history of the census, the categories have changed. The list has grown longer over time. And that's in part, it's a administrative and political negotiation over what you're allowed to check when you fill out the census form by way of identifying yourself racially. And I think that generationally, our understanding of what race is. So my son is Gen X and he's multiracial. And How he identifies himself actually varies from social context to social context. So sometimes he identifies primarily as Asian or Asian American, sometimes as Japanese American, and sometimes as multiracial. It just depends sort of what he thinks is most important in that particular situation. So he doesn't regard it as a fixed biological set of characteristics, and yet some people do. And I guess my particular concern, as I said in this talk, is that that notion that race is biologically fixed and that biological difference matters is I think problematic. And then the question about ethnicity is, again, it's, I think, largely a social understanding. The geneticists use it, especially the population geneticists are uncomfortable with talking about ethnicity. But here's an example using myself. So I identify as Asian or Asian American, and I recognize that's a racial category. I try to embrace that as an affirmative part of myself. But I also, in some circumstances, identify as being of Japanese descent. So I'll call myself Japanese American, for example. I don't know to what extent that's biologically accurate. So to me, I'm claiming it as a social identity because I was raised, right, in a family that identifies as being of Japanese descent by my parents and grandparents. So I hope that explains it.
Yeah, thank you. Actually, this is jumping back to the medical consent again. There's actually several more questions on that, which is not surprising. If a person has a unique condition, would it be advisable for them not to sign the form you showed giving medical consent if the object to the specific part of the consent, which you pointed out, will then be unable to receive medical treatment you need?
Yeah, that's a call that everybody has to make for themselves. There's some interesting, I can't answer that for any one person. So you have to decide. It might be possible, for example, that you go to a different doctor who's not going to use your cells and tissues for research purposes and for their own potential commercial gain. So to some extent, it depends on the trust you have in your particular doctor and in the research institution that they're affiliated with. But like I said, I'll give you two examples. So one, there's the story of Ted Slavin. Ted Slavin had hemophilia. So he lived with it all his life, which means that over his life, he had received many blood transfusions and platelet infusions. And he'd been exposed to different diseases, including hepatitis B. And his body had actually produced high levels of antibodies to hepatitis B. And when that was discovered, he was told about that. And so he thought, I can be of real use. Maybe somebody can identify more accurate tests for hepatitis B and maybe even better treatments or vaccines for hepatitis B. So in a sense, he sold his blood to researchers that he thought would have the best chance of making those breakthroughs to help other people with that disease. And eventually he narrowed it down to one particular researcher who he thought could develop something like a vaccine. So that's one particular model. There's also somebody else who I'd like to mention. There was a story about her earlier this year when her name was finally revealed. She is also biologically unique. Her name is Lorene Willenberg. She's an amazing woman. She's given not only a vast amount of cells and tissues and her time, but also her heart and her considerable brain capacity to trying to help people, the researchers who are trying to make breakthroughs to treat people with HIV or develop vaccines to HIV. So she herself was diagnosed with HIV, but it cleared from her system. And it turns out that it's almost undetectable in her body. So there's a small group of people who are capable of doing this, and I'm not going to go into the details, but in part because of all the contributions she's made over the year and a foundation she created to sort of collect these people on behalf of that research, remarkable progress has been made in the past few years. So that maybe very soon we'll have not only accurate tests and understandings of the disease, but maybe better ways to treat people who have HIV and vaccines to prevent, more effective vaccines to prevent infection with HIV. So some people sort of deliberately used, right, their biological uniqueness to help.
Good, good. Okay, so along those same lines, coming at it from a different direction, if you don't give consent to additional research, can the collector, for example, 23andMe, Ancestry, still maintain unused samples or records of your test results and later try to use them, for example, when you die?
Oh, that's a good question. Well, supposedly they're not supposed to be able to use it without your consent. The question about when you die, it depends. So if it's been collected for research purposes and it's being used in a way that counts as human subject research, then it's regulated by federal rules that are supposed to be for the protection of people who participate as human subjects in research. But under those rules, human subjects are living people. So once a person dies, then they are no longer human subjects. So that's one aspect. But in other contexts, you may not be a human subject. So you may not be part of what is called research, because research also has a legally specific meaning. So I suppose it's possible that your cells and tissues could be used. Part of it depends on the original language in the form. I've noticed over the years that the forms used by these direct-to-consumer genetic testing companies are getting longer. In some cases, they're getting better about disclosure and consent, but you have to read them very, very carefully. The longer they are, the harder they are to read. And the longer they are, the harder they are to understand by the person who's signing. Most people just want to get their test kit. They want to send in their spit sample and get the information that they hope is going to be interesting to them.
Okay, here's one especially for a professor of law. If courts came up with the ideas of ownership via discovery of land or discovery of cellular significance, couldn't the courts be used to reverse those decisions?
Yeah, I mean, for example, the Moore case only has direct precedential value in California. And I suppose it could be reversed by the California Supreme Court, and that would be effective only in California. But courts overrule cases very seldom. So once a Supreme Court issues a decision, then it's considered law. So, and it's law that could be overturned by a legislature. So the legislature could enact a law that modifies the effect of that court decision, or the court itself could overturn the case. But courts, as I said, do that very, very selectively. The Johnson case has probably been modified over time. The assumption is that we don't have any more land to discover within what we now call the United States. So that aspect of it is, in that sense, no longer relevant. And it's too late to change the effects of that case.
Okay. Question, I had thought that naturally occurring substances could not be patented. Is that still true?
Yeah, that's a really good question. That is true. It's just, you can't patent something in nature. You can patent something to which there hasn't been a human contribution, something that changes it. So there's a case called Myriad Genetics. And Myriad Genetics is a company that filed a patent and described the scope of that patent in very broad terms. And the patent that was at issue in this case, was a patent for the gene sequence used for testing for the presence of BRCA1 and BRCA2, which are, it's a gene sequence that if it has certain mutations in it, can cause certain forms of breast cancer, aggressive forms of breast cancer. So having a test for that form of breast cancer is very, very important. The challenge to Myriad Genetics was that when you challenge something, it's in nature, it's a gene sequence. And the response by the court was to narrow the scope of the patent as it was described by Myriad Genetics in its patent application. But the court also said that the process of extracting the gene sequence from the gene itself results in a modified form of that gene sequence, and that can be patented. So there are gene sequences, many gene sequences that have been patented.
Wow. Okay, so here's a Supreme Court question. The U.S. Supreme Court case denying Indian ownership rights justified the conqueror's right to the land. I believe this is the doctrine of discovery. Do other societies and countries have similar court justifications like Canada, Australia, and so forth?
So in the Johnson versus McIntosh case, there's no specific citation to cases, but to the longstanding practice in European, largely Western European, among Western European countries at that time. So this is they're talking about the 16 and 1700s, sort of the era of exploration by those particular countries, and how, in a sense, there was maybe not a formal treaty among those countries, but a tacit understanding that the discoverer got the rights to those lands, irregardless of the fact that there were people already living there. And that the discoverer who then went on to conquer or purchase the rights to those lands from the people already living there, right, got the rights to declare themselves, in a sense, masters of that land. So other countries have used that as a matter of practice. I'm not familiar with the case law specifically.
Okay, here's an interesting one. The medical profession has long used race, and this is more of a comment, and maybe you can comment on the comment. The medical profession has long used race to assist in interpretation of certain lab tests. This has proven dangerous in certain circumstances and is under review.
Yeah, I agree. It has proven damage. I mean, I gave you sort of two simple examples. In a lab test itself, there was the practice, as some call it, has been called racial profiling. So it's used in diagnostics, for example. A few years ago in the New York Times, a doctor named Sally Satel wrote an article, and she said, I'm a racially profiling, I've got the title slightly wrong, but she says, I'm a racially profiling doctor. She talked about the efficacy of using race as a proxy for genetic difference and how that might help you get to a diagnosis more quickly. But the examples I gave are meant to illustrate the dangers of equating race with genetics. So I agree with the comment.
Okay. How do you feel about the NIH program, All of Us?
Oh, that's a good question. I have mixed feelings. So on the one hand, so for those of you who are not familiar with it, All of Us is an effort to build a public biobank with genetic samples. And part of what they're doing is making a call to make it racially diverse. So when I'm feeling hopeful, what I'm hoping is that when those genetic samples are used from the All of Us biobank, that they'll do it to identify in specific terms what really matters genetically, and then to what extent health disparities by race are attributable to things outside the human body, right? To things that are not genetic. So that we'll have a much clearer understanding of the role that structural racism, interpersonal racism play in the formation of inequalities in health status.
Yep.
On the other hand, it could result in the perpetuation of the problems I've been trying to describe here.
Well, I want to comment on that because I've joined that, and my understanding is that your data goes into a big data bank, and then you're assigned some random number which is not related to your name or address or anything like that. Is that correct?
I don't know. I don't know what the process is specifically.
Okay, I was just curious. Okay, so we have one more here. How would I donate cells for research? I'm not quite sure.
How would you go
fits here.
forward and do that? So, I mean, you could sign up for a company that uses cells for research. You could sign up for 23andMe. They're actually using their biobank to do their own research. So that would be one way of doing that. And read your form carefully and consent to the use of your spit samples for that purpose. They'll probably also want to use the information that you submit on the form, in which you provide a lot of personal information, because that makes the cell and tissue samples all the more valuable, if you will, both in dollar terms and for research purposes.
Okay, and then this is the last question, since we're running out of time. And this goes along with your 60 Minutes interview. Do you recommend against uploading a DNA sequence to GEDmatch and other genealogical services? And if so, why?
I guess it depends on sort of what your particular values and concerns are. So the concern that I talked about when I was on 60 Minutes, and I think that the question gets to here, is that there's always the risk, right? This information is being digitalized, and we certainly know that any digitalized information that's available, even if it's not on the internet, right, is hackable. So your privacy may be compromised. On the other hand, maybe the information you get by participating in that DNA bank is important enough to you to overlook that risk.
Okay, so thank you very much, Lisa. That was a fantastic presentation. And I am certainly looking forward to taking a look at the video when it shows up. A few closing slides here. We make a donation after each of these programs to the Seth Nelson Student Emergency Grant Fund. This is for students at Sac State who have run into sudden financial emergencies and need some quick cash to help them to tide themselves over. And we would also like to give a year honorary membership in the Renaissance Society to Lisa Ikemoto, in appreciation for your presentation today. So thank you again, Lisa. Okay, and with that, today's presentation was recorded, as I mentioned previously. And if you go to YouTube, type in the Renaissance Society Forum channel and include Ikemoto, and it should take you right to a recording that will be available within the next couple of days. So with that, I would like to say that don't forget about next week. We have on the Friday the 24th, Chiba James, who is the great-granddaughter of a MODOK war soldier, and Dr. Rose Souza's war soldier, who is also part of the staff here, will be talking about the MODOK War, the most expensive military campaign in the history of the United States, where over 1,000 soldiers tried to defeat 50 to 60 MODOKs. It's going to be a fascinating presentation. We're looking forward to seeing you, and I think we're right at 4 o'clock. So thank you very much for attending.